All right, so welcome back, guys. Now we're going to focus on mensuration that is based on 3D shapes. When I talk about 3D shapes, you should understand what kind of shapes are included in your exam. So the very first one is known as cuboid. There's another name to a cuboid as well, and I would expect that you should know that, which is a rectangular prism. So let me write this down. Rectangular prism. And similarly, we got a prism as well. When I say prism, that could mean rectangular, could mean triangular, could mean trapezoidal, could be anything. And you'll understand how to figure this out once we start doing the questions. In a similar way, we have something known as a cylinder. I would expect that you should be very well equipped as to how these shapes look like. So just to give you an idea, this is a cylinder over here. So that's how my cylinder looks like. This part over here, let me just kind of highlight this. Just this. The surface over here, not the ends, just the surface. This is what we call as the curved surface. That's known as the curved surface, the whole curve. It's kind of hard to explain in a video. I wish I could do that in person, but try to understand as much as you can. In a similar way, we got something that is known as a sphere as well. Again, we will discuss the formula for volume, we'll discuss the formula for surface area, and you'll understand how this works. In a similar way, we got pyramid as well, we got a cone as well. Honestly speaking, you don't need to memorize these formulas, and I'll show you exactly what's given on the formula sheet. So if I were to scroll down over here, so far we have done these two topics. In the first part of mensuration, you saw that we discussed the very basic 2D shapes, and then we discussed the circle, arcs, and sectors, obviously. And then the question that we did, where we left the answer in terms of pi. Now, this is where it gets onto the 3D shapes, where it says surface area and volumes. And it says carry out calculation and solve problems involving the surface area and the volume of all the shapes that I've already listed. In a similar way, there might be a question that asks you to write down the answer in terms of pi. And they've given you that all these formulas are given on the formula sheet. It also says the term prism refers to any solid with a uniform cross-section, cylindrical sector. What they're trying to tell you over here is that this cylinder that we had, it's a uniform cylinder. What does that mean? It means it's straight. It's not bent. So there could be a cylinder maybe in this way as well. But that's not a part of your exam. So that's a uniform shape, and we only deal with uniform shapes over here. Let me show you what's given on the formula sheet. This is a screenshot of the formula sheet. Like I said, area of rectangle trapezium stuff is not given. However, they have given you the circumference. They have given you the surface area, which is obviously of a cylinder. They've given you the cone. They've given you the surface area of almost everything. And I would expect that you should be smart enough to identify the radius. You should be smart enough to understand that when I say L, it means the slant height. So just keep that in mind. H means the perpendicular height. So keep that difference, when you're doing a question based on that. Anyways, so that's just, how the formulas work. And I would expect that when you're solving any past paper question, you should go back and forth, see what kind of shape that is, and then go back, see the formula sheet, which one is applicable, just apply that. I could teach you how to make up these formulas as well, but that's just going to waste time. So let's not do that. As we discuss these shapes, you should understand that there will be questions when not a full sphere might be given, not a full cylinder might be given. So we might have something like this, but it might have been chopped in half. That means you might have something like this. So I can say that is just half of a cylinder. And whatever the formulas are given over here, these are for full shapes. So let's say if we talk about the curved surface area, which is 2 pi rh. But since now we are talking about half of a cylinder, can I just say that's going to be divided by 2, which gives us pi rh. So for half of a cylinder, that's the formula I will use to figure out the curved surface area. And I hope you do understand what does the word curved mean. Curved means just this part, not the ends. I mean, just the exterior side, by the way. You'll understand what it means maybe in a while. So anyways, now let's try some past paper questions. Again, there is a worksheet which says practice worksheet number 1, and it's based on all 3D shapes. So let's see what the question over here says. It says the sphere of a radius fits exactly inside the cylinder of radius r and similarly height of 2r. Calculate the percentage of the cylinder occupied by the sphere. So there are two different shapes that they're discussing. One is, of course, the cylinder, and the other one is for a sphere. So let's first figure out the volume of a sphere, which is given to us. And again, the same formula is given in the formula sheet. If you want me to highlight that, I can definitely do it as well. All right, a little to the right, and it's right here. V equals to 4 over 3 pi r cubed. So if I scroll down, let's use this. 4 over 3 pi r cubed. Now, question has already given that the radius is given to us as just r. That's it. As in, that means if I were to plug in 4 over 3 pi, instead of r, there's nothing else to plug in than r. So that just stays 4 over 3 pi r cubed. Are we even supposed to write down another step? Not really. Just one is fine. In a very similar way, if I ask you what's the volume of a cylinder, again, you can cheat it from the formula sheet. That is pi r squared h. If that is the case, well, pi r is r. But instead of h, we know the height of the cylinder is something that's given to us as 2r. Just remember that they're asking us the volume. So that's the reason why I'm taking that. Not asking us the surface area. That is why I wouldn't take the surface area formula. Anyways, if I did this, that's just going to give me 2 pi r cubed. This is the formula that I end up getting for cylinder for this question. So now comes the tricky part, which is to figure out the percentage. Whenever we talk about percentage, let's say your score is 20 out of 30. How would you do that? You wrote down your obtained over total, and then you multiply it by 100. That's how you figure out the percentage of your marks. In a very similar way, I'll do the same over here as well. Now, my question to you is, which shape is inside? So I had a cylinder, and inside the cylinder, I'm having that sphere. So don't you think if I were to figure out the percentage, shouldn't the sphere be inside? Which means we should have 4 over 3 pi r cubed in my numerator. In my denominator, I should have this 2 pi r cubed, and then times 100. If that is the case, r cube and pi cancel out. Similarly, if you start simplifying this, you should end up getting, okay, I'm just going to use a calculator because that is allowed. So this ends up giving you 66.666666, which is, again, I can write down as 66.7%. That's it. You see how easy this is? Let me tell you the kind of mistakes I've seen. I've seen some students taking the cylinder in the numerator because they think that's how it's phrased. Calculate the percentage of the cylinder. You have to see in which context are they saying. Occupied by the sphere. So they're asking us how much percentage does that sphere, actually occupy of that cylinder. So this is how we do it. I hope that makes sense. Now let's move on to another question. Now this question over here says, the diagram shows a plastic cup in the shape of a cone. Again, what's the volume of the cone? It's again given in the formula sheet as well. And they've already stated this. Again, this is an old past paper. That's the reason why they have stated this in the question. In your exam, this would never be the case. I'm talking about the actual CI exam. So now it says the diagram shows a plastic cup in the shape of a cone with the end removed. The vertical height of the cone is 20, and similarly, the height of the blah, blah, blah. They're asking us, show that the radius is equal to this. Now, you need to realize something. Mensuration is not just going to be based on mensuration. There might be concepts about, the SOHCAHTOA, the Pythagoras, the similarity, blah, blah, blah. All those concepts, they kind of mix up, and then you get a question like this. Now, in this case over here, you've already done this. When it comes to similarity, can I say two rectangles are similar? Yes, this is a rectangle. This is a small rectangle. Can I say all rectangles are similar? I mean, yes, one of them is going to be bigger, the other one is going to be smaller. But at the end of the day, they're similar. They should have a fixed ratio. If that's true, can I say all circles are similar as well? The answer to that is also yes. In a similar way, can I say all cones are similar? Some are bigger, some are smaller. At the end of the day, the bigger one is similar to the smaller one, right? So there's honestly no difference in, or there's no harm in saying that all cones are similar, all triangles, not triangles, I mean, all isosceles triangles are similar. So I can phrase my sentences in different ways, and that's going to be correct. So if that's true, that means all spheres are also similar. In other words, that means all cylinders are also similar. You see where I'm going with? Now, if that's the case, that means, Bachid, this cylinder is also similar. So I could say, well, this entire thing is one cone. Let me just draw this out separately. That's one. And they're asking us the radius of this cone. This cone has a height of 20. Just kind of drawing this outside. However, if I were to draw the smaller one inside that has been removed, I can say that's the smaller cone. And in this smaller cone, I know that my radius is 2.7. I also know that my height, if the whole thing is 20, this is 8. Can I say 20 minus 8 is just going to give us 12? That means the height of this is 12. I just said all cones are similar. If that's the case, can't you take out the ratios? Can't you say R ratio of this over ratio of this is equal to the height of this over the height of this? If that is the case, I multiply and I end up getting the answer as 4.5, exactly what they wanted. I kind of love these questions. Why? Because they've already stated the answer. So I know that I have to prove this. And I hope this kind of makes sense. The question that I get is, what exactly are we supposed to show in our working? Just this part. That's completely fine. Anyways, now that we have done this, now that we know the smaller cone is this much, they're asking us calculate the volume of the water in the cup when it's full. And they've already shown you that this is how the plastic cup looks like. This cup is something you could say that's kind of a cone, but not entirely a cone. It's just the top part of the cone. But how did we get this top part? We've already done this kind of question when it came to sectors. And we have to use the same logic over here as well. You figure out the whole volume, and you subtract the volume of this cone that is not even a part of it. So I can say, I can do it separately, or I can do it in one step. So I can say volume of the bigger cone, which is the red one. When I say the red one, that means I'm talking about this one. So volume of big cone. The formula is again given 1 over 3 times pi r squared. What's r in this case? We just figured it out as 4.5 squared times height, which is 20. That's for the bigger cone. Now the smaller cone is this one. The smaller cone has a radius of 2.7 and a height of 12. So I can say volume of small cone is going to be 1 over 3 pi, formula is given, I'm just cheating, 2.7 squared times 12. If I were to calculate both of them, I believe the first answer is going to be 135 pi. You can convert this into a fraction. And the second one should be kind of weird, but that's completely fine. That's going to be 729 over 25 pi. This is a paper 2 question. And usually, for those of you who know me, they know that I like to keep my answers as accurate as possible. That's the reason I'm not converting this into a decimal number. And I'll just say, okay, volume of the cup, which is exactly what they want, is by subtracting this. So 135 pi minus this in my calculator. This ends up giving, now I can convert this into a decimal number. So this would come out to be 332.5. But I know that my answers are always meant to be written correct to 3 significant figures. If that's the case, then I can round this off to 333. That's the answer over here. Now, some of you might be wondering, isn't this fine? That's completely fine, but you need to realize in the recent past papers, and you'll see that this is also written in the Martin scheme. That's fine, but still, when it comes to these kind of questions, please, everyone, I beg you, always round off. That's just the way how Cambridge recommends. If you want me to share a principal examiner report where it says that, I can show that to you as well. But trust my sources and trust me when I say that it has to be rounded off. Honestly, I don't think this topic is hard. I think you just had to figure out similarity, figure out the ratio, and then end up getting the radius. Once you have that, then you can just easily figure out the volume by cheating the formula. Not, I wouldn't call that cheating because it's given to you. So you're just doing what's given. So, anyways, so that's how it works. Now let's try another one. It says a solid cone has a diameter of this. You should know that when I say the word diameter, that means radius is going to be half of that. That means that's going to be 4.5. If that's the case, they've given us the slant height. You do realize that they haven't given us this perpendicular height. And did we not do that question about isosceles when I was teaching mensuration for 2D shapes? Did I not teach you that you can form that 90? And that's true. This is the height that we need. Not in this part. Obviously, we need that in the second part, which is something we'll have a look. But let's solve the first part. So the first part says calculate the curved surface area of the curve. This is the curved surface area, all of this. Now, if that's the case, they've already given us the formula, which is pi RL. That means that's going to be pi, radius is 4.5, and L, which is the slant height, it's given to you as 10. That means you should end up getting 45 pi, which probably translates to, in my calculator, this comes out to be 141.37. So I can just round it off to 3s7, write it down as 141. The next part, however, says that you have to figure out the height. Now, in this case, we already know that this is going to form a 90. We know that's how the triangle looks like. What does the base look like? I just said if it's given to you as a diameter, that means you can take half of that. So this clearly means that's going to be 4.5. The slant height is 10. And this is the perpendicular they're asking us. So I would expect that you should know how to use Pythagoras. If that's the case, hypotenuse squared equals to base squared plus perpendicular squared. So let's just plug in the values. I know my hypotenuse is going to be 10 squared. I know my base is 4.5 squared. And I know that perpendicular is what they're asking us, which is 8 squared. I move it on the other side, take the square root in my calculator. Aren't we supposed to show that step? You can. Obviously, you can. How much is this worth? 3 marks? I mean, sure, you can. 10 squared minus 4.5 squared and then 8 squared. So H, now I can do it directly. If I put this in my calculator, this comes out to be 8.93 correct to 3 significant figures. So this is how you do it. I wish I could actually try to show you these objects and tell you how these formulas, they exist. But again, that's not relevant to your course anymore. So there's no point. Now, this is a compound shape. I told you earlier, if we had a sphere and if I were to cut that in half, I believe I didn't show that. So let's have a look. So this is one whole sphere. And if I were to divide that in equal halves, if I were to chop it in 2 equal halves, each half is known as a hemisphere. That's the vocabulary I would expect that you should know. I've taken this screenshot from Google, so I think this is quite evident as to what does the hemisphere now look like. So I can say this bottom part away, this dome shape, that's a hemisphere. And what does the top shape look like? Does it not look like a cone? So if you kind of tilt your neck 180 degrees, you don't have to do that, by the way, you're going to break it. Just kind of tilt the screen and you should see that it's more of a, I don't know, it seems like, a cone that's with ice cream, a perfect scoop. So anyways, now it says the diagram shows a solid made up of a hemisphere and a cone. So these kind of questions, we call them a compound shape. The word compound shape means it's not just one shape, it's a mixture of both. That means you'll figure out whatever they're asking us for each individual shape and then add it up. So the first part of the question says, calculate the total volume. You see what's happening? When it comes to the total volume, that means you'll first figure out the volume of the cone, you'll figure out the volume of the hemisphere, and then add this up. So let's do it individually. Volume of cone. Again, it's given in the formula sheet. They've already stated this over here as well. 1 over 3 pi r square h. I can say 1 over 3 pi, cone is this, by the way. The radius is given to us as 7 squared. Height is given to us as 13. If I put this in my calculator, this ends up giving me 637 over 3 pi. I'm writing it down in this way because I want to make sure that my answer is very precise and it's very accurate. It's completely fine for you to write it down in decimal as well. If you do, just bear this in mind that you should be taking the exact value in the next step. So try not to round off, try not to take this value. If I were you, I would use my calculator and then just do the plus feature. Now, the next part says that you have a hemisphere. So in your formula sheet, it's going to be given to you that a full sphere is going to have the volume as 4 over 3 pi r cubed. If I divide that in half, what does that mean? Divided by 2? Can I say divided by 2 is the same thing as multiplying by 1 over 2? So don't you think the volume of a hemisphere, the formula that I will have, should be 2 over 3 pi r cubed in its simplest form? They have given this. I'm just trying to make sure that in the kind of question that you might come across, if it's not given, and if in the formula sheet they've given you for a full sphere, you should make this up on your own. Mensuration requires you to improvise. Now that we have this, the radius is same. So the radius of the cone and the hemisphere, that's the same because they're both attached. So I can say that's going to be 2 over 3 pi. R is going to be 7, and then we have cube. Don't forget it's cube because I have seen some students taking that as a square. So just kind of making you aware of the kind of mistakes I've seen over the years. 2 over 3 times pi, and then we got 7 cube in my calculator. This ends up giving me 686 over 3 pi, which is, of course, in 0.78.377. Or I can write it down as the exact value, which is 686 over 3 pi. So now it says the total volume. Well, that's kind of easy. Total volume is equal to the addition of both of them. So this plus this. 718.377 plus 667.064. If I were you, I would take the exact fraction so that my answer is very precise. And that's exactly what I'm doing right now. This ends up giving me 441 pi, which is 1385. 1385 as my answer, 0.44. Please bear this in mind. This is a wrong answer. Why is that wrong? Because I said all the values should be rounded off correct to 3 significant figures. So can I say that 5 rounds off and this makes it 1390? So this over here is going to be my final answer over here. I hope this kind of question makes sense. I know it's kind of tricky, but I don't think that's too hard. It's just using formulas. That's pretty much it. And they're already given. In all the recent past papers, we see that in the exam paper, there's always going to be a blank, and then they write down the units. So in this case, I'm already mentioning because this was 13 centimeter, blah, 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 7 centimeter. So I know that this answer, since it's cube, I mean, it's volume. So that has to be 1390 centimeter cube. Now let's have a look at the next part. It says the solid is made of wood and 1 centimeter cube has this much mass in grams. How much mass, how much volume do we have? So you said volume is 1390, but again, what's the exact figure? It's 1385.44236. You need to realize that you rounded up your answer for the first part. That's perfectly fine. But in the second part, if it requires you to use your answer for the first part, you have to take the exact value, not the rounded off figure. That's the answer to the first part. So it says 1 centimeter cube 1 centimeter cube has this much mass, 0.94 grams. How many centimeter cube do we have? 1385. So can't you say that if I were to multiply 1385 on both sides, exact value by the way, dot 2, blah, blah, 2, 2, 2. If I multiply this, can I say that the mass is equal to multiplying 13, blah, 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 85 point something on both sides? So I would show that working. 0.94 times 1385, 0.44236. Don't show all of that, just do that in the calculator. Times 0.94. In my calculator, this gives me 1302.31 dot 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 grams. The question says write down your answer correct to 1 decimal place, but that has to be done in kgs. So don't you think 1 kilogram is equal to 1,000 grams? You should know this conversion. I'll post the conversions as well if you want, but these are very essential. That means you're supposed to divide this by 1,000. And if I did, that means my final answer will be 1.302 dot 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 kg. But they said round off your answer to 1 decimal place. That's it. 1.3 kg. If this did not make sense, please try to watch that again. I just wrote the question. I knew 1 centimeter cube represents this. I got 1385 centimeters cube. I multiplied it on both sides. That gave me the answer in grams. Why? Because 1 centimeter cube represents this much grams. So that's how you do it. Now that we are done, it says calculate part B, where it says to find the curved surface area. Curved surface area. I'm just going to kind of take the question out because I feel like there's a lot of mess. Curved surface area. And they've already given us the formula as well, that for a cone, it's pi RL. So let's first figure out the curved surface area of a cone. Curved surface area of cone. This is again given in the formula sheet. I'm kind of repeating the same thing again and again, just to make you realize that it's not difficult. It's just, you just require practice on this concept. That's it. Radius pi r, which is 7. L, what's L? The slant height. Do we have the slant height? No. I got the perpendicular height. I got the height which is vertically up. That means if this is 13, then this is also 13. You see where I'm going? There has to be a 90 over here. That means again you'll use the Pythagoras. So I can say if this is L, the slant height, L squared is equal to 7 squared plus this height was 13, 13 squared. I solve this in my calculator. I end up getting 218 square root of 2 point something, which is 14.76. Now I can just plug that in, 14.76. Again, try to use the precise value, times pi, times 7. If you did this, that's just going to give you 324.695. But again, this can be rounded off, and we can say the answer is going to be 325 centimeter squared, because it's surface area. Area is always square, volume is always cube. They were only asking us to find the curved surface area of the cone. That's the reason why we have done this. If I ask you, find the surface area of the hemisphere as well. So if you check out the formula sheet, you'd realize the surface area of a full sphere is equal to 4 pi r squared. So can I say for a hemisphere, that means half times 1 over 2? Simplify, you get 2 pi r squared. Now you can plug in the radius, that is 7. Although they're not asking us, I'm just going an extra mile over here to make you understand if this kind of question shows up, this is how you do it, which comes out to be 307.8, which again rounds off to 308 centimeters squared. So I hope, guys, this is clear. We'll probably continue this in another video as well with some more questions. Till then, adios.